Welcome, everybody. We are going to be working today on continuing our work in Unit 2. And in Unit 2, we last week got through sections A and B. So we talked about functions, and I'm noticing here that that is misspelled. So I got to fix that typo. Um, Heck, I'll just do it right now, even though it's going into the video. I know that's kind of silly, but you know what? Ultimately, what this tool is, that being Blackboard, is just a content management system. So that's how easy it is to change it. Right, just click edit. Now you guys can't do that, of course, thankfully. But we did get through functions. So we learned basically, just to kind of recap a little bit, functions are a block of code that has a name attached to it that can contain a bunch of statements that you might repeat, right? And then instead of having to retype all those statements, you just call one function call and it runs all of them. And a real big takeaway with functions is that you can declare a function, but it doesn't mean that it executes until you call it by name. So always remember that. So I will have students that like, man, I typed up the function, it just doesn't work. And it's like, well, you never called it and you never asked it to run, right? So defining it is different than running it. And I think that's pretty important. Then they started talking about types. And if you recall with types, we looked at really kind of a few different things. We dove deeper into the numeric types and we realized that there's integers, right? Counting numbers, and that there's what they call doubles, which are basically decimal values or floating point values. And then we also have strings, and depending on how you apply those data types, like how you create something, it is either implied what the data type is, or you can specify. And then we also learned some hard rules like when you're working with two different data types, like numerically, like if you have an integer and a double, you cannot do math with them, although you can do math with them in a print statement, which is kind of weird. So it teaches you a lot about how this language operates. And data types are always really, really important. We're going to move on today to hopefully cover both sections C and D. We'll see how far we get. But we're going to start with the playground that's attached to parameters and results. So I have that open up here in my file or my Finder, excuse me. This is what happens when I go from Windows to the Mac, right? 10 minutes ago I was on a PC, I'm calling it the File Explorer. Now I'm on a Mac and it's a Finder. But here we are with the parameters and results playground, and I'm going to go ahead and open that up. Of course, Xcode is launching on my other screen here, and I'm going to go back to the first page on this and take a look. I do want to, just kind of reiterate for you guys, like, all the little toolbar panels and stuff that we have here, like we've been kind of learning this in Xcode now, and some of these are actually kind of functionally useless really in terms of how we work with the playground. But I do find it kind of interesting how it kind of breadcrumbs out, and that you can actually dig into all the backend files that go with something, if they were here, right? But you can also navigate all the way through that project. And I think you guys have kind of figured that out, generally speaking. But if, like you did what I just did, which is I came into it and it was on not the first page, that's how you get back to the first page. That's why that's important. All right. Now we're going to do a little recap here again, because in order to do this next section, we do have to talk about functions again. And what it's indicating here is it says when you learned about functions, you called them like this. So, and that goes back to what I just said, right? You can create a block of code, but it doesn't do anything until you call it by name. And look at how both it's named and where the parentheses are placed. So whenever you see a name and there's parentheses after it, generally speaking in programming, this refers to either a function or a named object of some sort that you're calling in. Typically it will be a function. So this I think is kind of interesting. And normally when we run a function, if we don't need to send it any data or information or control stuff, we leave those parentheses blank. And then what it does is it just goes into the block of code and executes all the statements that you have. That's kind of the general approach. But weirdly, when we first started coding, we were using a pre-built function, one that's just part of the language natively, which is the print function, which we were feeding into it what we call a parameter, right? And okay, so there's also kind of two different terminology things going on here, and I'll talk about this more as we move forward. So in some languages, when we're programming, we call the stuff inside the parentheses arguments, and in other cases we call them parameters, right? And I'm going to just functionally say that for most programmers, those two terms are interchangeable, right? So if you hear somebody say parameters or arguments, they're kind of the same thing. And the truth is there is a proper way to utilize that terminology, but it's relative to where you sit in the code. And most programmers never wrap their head around it. So even pros, by the way. So stuff inside the parentheses is typically called parameters or arguments. It just depends on your perspective, right? Now the print command, and they say here, it has to have a value inside the parentheses. That's not actually technically true. You can run the print command with empty parentheses, and then all it does is it creates a blank line, by the way, right? So that's not entirely true. You know, but it is true that it would be pretty useless without putting something in there. I'm going to argue that printing a blank line sometimes is not useless at all. And that's actually sometimes a useful thing to do. Now, what we're going to start learning is when we create code, how we would put values inside those parentheses. And by the way, when we're doing that, we call that passing values. You know, so we're passing a value to a function. All right, so let's take a look at the next example here. All right, so now they want you to do a little bit of recall, and they're saying, hey, do you remember how to create this? All right, so in Swift, the keyword for creating a function is func, F-U-N-C. All right, for those with experience in other languages, often, you know, like because many of my people are coming in with Python experience these days, in Python, what we do is we use the keyword def, D-E-F. In JavaScript, we use the keyword function. In Java, the full-blown programming language, we use also the keyword function. And then if you learn like C# programming or other C languages, typically the keyword is function, but sometimes they call them subs and a couple of other things. But generally, Swift is really not that much different than any of these languages, but it is just a four-letter func. There must be a reason why they didn't use the whole word, and I think it's just for efficiency. All right, so you use the keyword, you give it a name, right? And they do recommend generally that you use camel casing for this, right? And I don't know if you guys caught that. It's not necessarily a rule, but it's a convention, followed by a set of parentheses, which so far we've learned to just leave blank. Then you have this set of curly brackets to open and close. That is really truly what defines the block of code in this language. Thankfully, unlike its root language, Objective-C, we are not obliged to add semicolons at the end of the statements, right? We should be thankful for that because that's kind of how it is in Python. Also, we don't add semicolons. However, okay, so this is the big however. It's still at the root. This is still working on top of Objective-C. So in some cases, there are situations where you might actually use semicolons. They don't talk about that here, but I'm just kind of giving you that piece of info. So generally speaking, we put one statement on a line. No semicolons are necessary, but we do have the curly brackets defining it. So once it's defined, then we can call it by name, and you can see the output here, right? That hello Johnny runs. Where does it run? It doesn't run over here, right? So this line does not run in the side panel, but it runs down in the console. So it gives you the output down at the bottom. So that's where hello Johnny is coming from. All right. So if I wanted, in this case, right, you know, this one is really designed to say hello Johnny, right? It's because we've hard coded the name in there, and they're pointing out this is very specific. So if you wanted to say hello to Vikram, for example, you'd need to write a whole new function. Now, I'm hoping you can start to see that might be kind of inefficient, right? So in this case, wouldn't it be better if instead of hard coding the name into the function, that we made it possible that you can feed any name into the function and have it say hello to the person, right? And this is actually not an uncommon thing to do in programming. So if you think about this, like if you go to a website and log in, or if you run an app and you turn it on, or maybe there's a login or something, or a profile or something related to it, and you get a little message up at the top that shows like, oh, hi, Joe, or whatever your name is. So really common kind of programming activity. It's just helpful because for the user, they know if they're logged in or not, right? So this type of function is actually kind of practical in a way. All right. So what they're trying to point out here is, instead of writing a bunch of functions, each with their own name, to address each individual, which makes no sense, it's better to change the declaration of your function, as you see here, so that the function is generic in name. So we're not applying a person's name to it. We're just calling it hello. And then inside the parentheses, and I want you to look at the nomenclature of this, right? The way that it's being set up, we're setting up basically a name for a variable, in this case, is really what it is, and the colon, which then designates its data type. So we're saying that we have a variable inside the function named name that is a string. Now, this means that this information, when we run the function, needs to be populated here, right? So like when we call the function, we will feed in the name that we want to output. So here, we're doing the function call. So you can see we're calling hello. We're indicating that name equals, basically, and I shouldn't say equals, right? Because there's a colon here. We're just saying that the name variable is going to be Maria. And in this case, the name variable is going to be Vikram, right? And what they want us to do here to experiment, of course, and this, you guys should try this, of course, on your own machines, is to throw in the name. And then you see, and I'm trying to show you also, as I'm typing this in, how Xcode is kind of guiding me to do the entry. And I'm actually going to Command Z this a second, because I want to show that again. So I typed hello, I hit the parentheses, it found the function up on the page somewhere, and it's saying, oh, you want the name thing. Okay, so it's highlighted right now in my window. I'm just pressing enter, and then it automatically leaves string, which is empty right now, and expecting me to type a string with quotes around it. So I'm going to say, I don't know, Peter, right? And then once I have that typed in, it sends basically the information inside the parentheses to the function. The function receives Peter, the string, and then uses Peter to populate the variable to then do the output, right? You guys getting that to work, I assume, right? And this is really much, much better than what we had originally. So that way I don't have to write a hello Maria, hello Vikram, hello Peter. I just write hello, feed in the name, and then we're up and running. Now, if you think about this from a programmatic standpoint, right, like how you might write a program in the future, where does the name come from? Well, ideally it would come from the user entering it somewhere, or it's stored somewhere, or something like that. But that's how you would call it, and apply basically that string to that variable name that's part of that function. All right, so let's move on to this little exercise here, and let's try this out. All right, so this is like a little practice exercise. It says the following code prints the value of a constant to the console. So you see, it says, let favorite food equal cheese, and then I do a print command, which is my favorite food is, right? Notice the extra space there. And then we're concatenating, right? We're not adding the words, we're joining the words because they're strings. And so my favorite food is cheese, right? So that's the example. Now it says put the print statement above inside of a function that allows you to pass in any string as an argument. When you call the function, it should look like this. All right, so they're telling you how to call it before you create it. And this is kind of interesting, but let's kind of do this together. so I'm going to go ahead and create a function, and the name of the function is already implied. What is the function name I should use?
Cheese? Or no?
No,
Or
that's
food?
yeah. Print favorite food or print favorite, right? Because
Oh,
if this is how we're calling the function,
Okay.
think about this. If that's how we're calling it, that's the name of it. All right, so let's do that. So I'm going to say func. And, I'm just copy pasting here. I don't want to like mistype it. So we'll say print favorite, and then we know we need curly brackets. So you can do that part in advance. But the piece that we need is to feed in the name cheese. So we're going to put it here. So the food, or whatever the favorite food is, right? We're going to list it here. Now they're implying that our variable name is going to be food, right? So here I'm going to type food colon, and then I have to indicate its data type, which is a string like this. And I'm typing it totally in the wrong spot. All right, so I try to sound brilliant and then like totally an idiot. All right, so food.
For a second, I was like, wow, Swift is very different from some of the other languages I've worked with.
No, it's actually not, they have some ways they do things, yeah, but you have to still put the code in the right spot. All right, so here we have now inside whatever the name of that variable is going to be and its data type, so we can transport it in, right? Now, what we need to do is take the print statement, right, here, and I'm going to copy this, but of course we do need to tweak it, right? Because our variable is not called favorite food, it's just called food, and not with a capital F, but a lowercase f. So it is important, right? Obviously that this name matches this name here, right? Of course, we can experiment with that. We just, remove the D and call it foo, and just wait for the errors to fly. There you go. Took a little bit, but the errors are flying on it, so you can fix that. And then we need to call it, and to make sure that it works, of course, we can just grab this code and then add another line and paste. Now, hopefully, it will output. And I'm not sure if mine's like actually building here. I'm waiting for it to run. Did yours work?
My
Yes.
work.
Okay. Mine.
Did you go ahead play?
Yeah, I think so. All right, there we go. Let's see. Yeah, it's telling me my build succeeded, but I am not seeing it. Okay, so here we go. I'm gonna go through this process, and you guys have seen me do this before. I'm just gonna close this playground and reopen it. I hate doing that, but if it's not working, it's not working. So hopefully, or the question becomes, have I made a mistake? That's maybe a thought here. Did I make a mistake?
It looks like mine.
Okay.
I don't see any.
Yeah, I don't see any mistakes either.
The playground when I gave you that red X then.
Yeah, I'm tempted to kind of do like something like this, which is to break it and see if I can trigger it to break. But it's just saying build succeeded at the top. I don't know if you guys are catching that.
Yeah. I see
Yeah.
that.
Okay, so
Oh,
now
there
we
it's
go.
throwing some errors. All right, so that's good. That's reassuring in a way. Right. So now I'm just going to let it sit for a second. It should populate. So let's see what happens here. Waiting for it to populate. All right, I'm going to pause this recording here for a moment. All right, so now that the recording is running again, I basically had to completely, closing the playground alone wasn't enough. I had to actually close Xcode all the way to make it behave. But here's proof that it is working. Now, of course, the test of a function like this, of course, is also to repeat it, right? So like you can try a different food here, like, you know, M&Ms might be a good choice. There you go. So my favorite food is cheese. My favorite food is M&Ms. All right. So now what's kind of interesting here is they're making this other point. All right. So what if, okay, so this is how you pass one value in. How do you pass in more than one? And this is a thing that we do in programming very often because our functions can get more complicated and might require a bunch of values, right? And so they're kind of building us up to that right now. So it says, what if you wanted your function to take more than one value? No problem. Just list the parameters inside the parentheses with a comma in between. So for example, if you want to address somebody's first name and last name, so we're still following the same approach, right? The name of the variable, the colon, and then the data type, a comma, and then the next variable and data type. Okay, so this will beget the question, can we do more than two? You know, and the answer is yes, you can do a whole bunch, but then you start thinking about, is that the most efficient way to do it? Now, the other thing that we're kind of revisiting here, and I don't know if you remember this from earlier, I think it was a unit 1 thing, where when we were doing the print output and on the previous page, we were doing a string plus the variable, right? And that's one approach, and it works just fine in the print statement, but they really do like you to use this other approach, and I forget what this one was called. Does anybody remember what that one was called? Like interpolation or something like that, or some goofy term like that. So we'll have to like revisit that syntax because I don't remember what it is. But this is really kind of an efficient way to do it. So we use the backslash, and then inside parentheses, the name of the variable, backslash name of the variable. Now, the beauty of this is that it's in some ways easier than writing the plus with the quotes and making sure you got spaces in there and all that. So this is really Swift's preferred way to do it. All right. So now they're down here running the function, and notice how they're doing it. They're just feeding in first name Johnny, last name Appleseed, first name John, last name Snow, obviously watching Game of Thrones there or something, right? And you can see the output down here at the bottom, right? So they want us, of course, to experiment a couple more times. So go ahead and do that. So hello, and notice how I'm sticking here on this autocomplete on the screen, that it tries to auto-populate it for you. And my strong suggestion is when Swift does this, let it do it. So you notice I pressed enter and it filled in the variable names automatically. Thank you. I don't have to, you know, and why? I don't have to retype them and potentially make a mistake. They're correct, right? Because what it's doing is it's pulling them from the function definition. And now it's just waiting for me to type something. So let's, I don't know. Let's name another Game of Thrones character. Can anybody think of one? I can't think of it. Like, how about like Daenerys, right? And I'm not sure if this is spelled right, Targaryen or something like that, right? She's like the you know, the dragon mother.
Yes.
Right. And then, you know, try another. But mostly what I want you to get used to is this pattern of letting Swift autofill. And here, I'll just do this because I went to this concert last night. So may as well tip my hat a little bit to it, but you can see how it's working, right? And the tool, and I think that's really cool. Once again, I'll just demonstrate that first part of it, where you type in the function, it auto recognizes it. You can press enter and it helps you autofill. And believe me, that's a great feature. A lot of programming tools do not do this, right? And once again, for me, the big takeaway is it keeps you from making mistakes. Right. Now, you do have to remember, whenever you're typing in a string, you still have to put in the quotes. I can't just type in plain characters.
Yep, I just did that mistake.
Yep. Right. And so, hey, and what happens if you just type in plain characters?
it would just say hello, first name, the name that you chose, and last name. So
Yeah.
it'll just rewrite all of it for you.
Yeah, and you know what? It'll just give you those error messages at the bottom.
That's it.
Yep. All right. So I think we're good on that one, right? Let's move on to the next page. All right. So this one says the favorite food function you created is okay, but perhaps a little limited. What if you had a favorite animal or favorite color? So the following code is a more flexible version of it. So let's take a look at what they're doing. So they're saying let category of thing equal food, let favorite equal cheese. And so now we're going to say print my favorite category of food is, and then my favorite, and then the function call for that would be this. So what they're having us reverse engineer once again is we got to create the function, right? And then we have to feed the information incorrect. Now, once again, they're giving us the name that they want us to use. So we're going to use that. So we'll say func, and we'll say print favorite, spelled correctly, parentheses, and curly brackets. And I have this tendency where I tend to type through all that. I always like to make sure those curly brackets are closed, right? Because if they're not, then you got some real problems. Inside here, we're going to do exactly what they're pointing out. I mean, so I could actually just copy paste this, and I think I'm going to. But I'm also tempted to see what it does when I just type stuff in. So it's category of thing, colon, and then what do we put here? Is this a string? Number? It is a string. So it is a string. Once again, let it auto type if you can. Then we put a comma in, and then we'll do favorite. And that also is a string. Now, we should be able to just take this print statement up here, and I am going to potentially copy it, but then I'm also thinking to myself, it's always better to demonstrate the autocomplete. So if I say print, and then I get to choose what goes in here. So I want to say my favorite. And now instead of escaping out and doing a plus sign, we're going to use this approach, which they really prefer that we use. And it should find your names. I only typed one letter there. And then I get out of there, add a space, because I want a space in between the words, is space, and then backslash parens, favorite. I just type a couple letters and it pulls it up. And then really you should have punctuation at the end too, but that can happen after. So now, hopefully, and I say hopefully, if you did it all correct, right, now we should be able to type the name of the function, right? Notice how it auto-populated everything for me, like really quickly like this. So my favorite category of, I don't know, give me a category of breakfast items. How about that? Breakfast items. So what's my favorite? Let's say, waffles. Yeah, that's a good one, right? Lots of maple syrup and butter and whatnot.
Oh, yeah.
Mhm.
Yeah, and homemade, right? It's got to be homemade.
Oh yeah.
And hopefully that worked for you. So my favorite breakfast item is waffles. That's what I have. Now, yeah, those strings, and I want you to notice, can be more than just a word, right? So you can have like a phrase or a sentence or heck, a paragraph, really, a string can be pretty long. It just made more sense to me to say my favorite breakfast item is waffles than just to say my favorite breakfast is waffles, right? That because I am referring to a singular. My favorite breakfast would be waffles with eggs and bacon and a couple of other things thrown in.
Mhm.
But did that work for you guys?
Yeah.
All right. Now I'm getting an error here, and I think this is kind of interesting. Execution was interrupted. I'm not really sure why. All right. So let me. I don't know if that's problematic. The output's still happening. Use thread return dash x to return the state before the expression. Interesting. So there's not really a fix for that. I'm just wondering if I have to restart Xcode again. I'm just going to play it safe, you guys, and do that.
I think so.
Yeah. I think that's kind of weird. You know, okay, so as cool as these Apple tools are, so here's my little commentary on this. Sorry, Apple people. You know, if I'm working like like Microsoft Visual Studio, which is maybe kind of the equivalent of Xcode on the PC platform, it never crashes like this, ever, ever, ever. Mac being the much more stable platform, it impresses me to no end that it does crash a lot, which makes you wonder how the tech works underneath and why everything is so stable over it. So that's a separate question though. So we're getting philosophical on it. All right, let's move on to the next one. All right, so now we run into a different type of challenge. So if we're running a function and we can send stuff to it, can we run a function and get stuff back? Now, this is a really common thing we do in programming too. And often when we're expecting to get a value back, it's usually because we're doing some sort of math, calculation, adjustment, some sort of processing or whatever. And we're sending information to a function, and then we're expecting the function to do some work and then return what the answer is or the result or the output or whatever, and that we can use somewhere else in a program. So they call this passing a value back, and it's called returning a value. So we actually have a little statement in here called a return statement, and this is what we are returning. Also very, very common in programming with the same keyword to say return. Now look at how we break this one down. So we will actually have here the same kind of function declaration, and then here now we're starting to see an integer thrown in instead, and another integer. But look at the tail end right after the declaration. This is very Swifty, you know, as we'll call it that, right? The Swifty way of doing things, which is they are indicating after the parentheses that we are returning something, and they're also indicating what data type that return item is. So this is a really important takeaway here, because we're going to do calculations and whatever, but what we're going to return is a string, and you can see it down here. And so there, you have to declare what data type the output is. And if I instead removed this and just typed a number, it would fail, right? This is also very common in other languages. I'll say Python is an exception because you don't have to declare your return type, it just works. But in Java or C or C# or a formal language, you do have to declare what you're returning, otherwise it breaks. So this is how we do it in Swift. And notice it's just a dash and then the greater than sign, which is the shift of the period key. Excuse me. And it kind of forms, a little arrow is what it does, right? And then you point to the string type. All right. Now, look at what this one does. Let's kind of try to figure out a breakdown of this function. It says the space available message. All right, so we're going to run that. So that's what it's called. And what they're trying to figure out here, so if you think back like how we did those iPhone calculations way back, so like how many minutes of video you can fit on your phone, this is kind of revisiting that a little bit. So here we would feed into it each video duration, so like I'm assuming in minutes, and then the number of videos as an integer as well. So when that feeds in, this will go into this spot here, number of videos will go here, and then we have a couple of things that are declared inside here. So the current space is hard-coded for whatever reason. The megabytes per video seconds, so 3 megabytes per second for video. And then they all already have the calculation figured out for us. So it's the current space minus each video duration times number of video times megabytes per second. And if you remember the order of operations for math, all that multiplication happens first, and then that's subtracted from the current space. Then we'll take what the variables all resolve to, or what were fed in, and then make them part of a string. So if your number of videos are whatever the duration is, you'll have this much space in megabytes remaining. So they're concocting the whole thing. And then they run the function. So each video is 10 seconds. We have 50 videos. And then of course you can see the output in the sidebar here. If your 50 videos are 10 seconds each, you have 8,500 megabytes remaining in your storage capacity. All right, so that's a demo of how it works. All right, so now it says your function can have multiple parameters, but it can only return one value. This is an important takeaway too. So when you're building a function, you can throw 10 pieces of information at it. All it could send back to you is one value. All right, so that takes some planning then. So like, what are you doing with what's coming back? And what is it that you really need to come back, right? So like, for example, if I was determining the circumference of a circle with a function, what I want to come back is the circumference. It could come back as a number, it could come back as a string, it just depends on what you're doing next in the program, ultimately. All right. Okay, the value that a function returns is just like any other. It can be assigned to a variable or a constant and can be used for other work. So variables and constants can also be used as arguments. So here's where it gets a little deeper, right? And this is very true in all functional programming in every language. Often when we're calling a function like this, if I just run the function straight, right, and it's returning a string, right? So, all right, so the output, it's not really output. This isn't printing to the console. This is kind of an interesting thought here. So if I did want to print it to the console, how do I get it to print? Well, there's no print statement anywhere here. I don't know if you guys are catching that piece. So here, they are hard coding the values that we're feeding in. So desired video duration goes here to run the function. Holiday video count goes here to run the function. We call the function, sending that information. What does the function return? A string. So the string comes back with those values put in place. And then we're setting that into, in this case, a constant. We're storing it, right? And then I'm once again taking that text or string and feeding it into another string, which stored in another string. And so if you look at like kind of the byproduct of what's happening here, right? So look at the output. So got one hard-coded value, another hard-coded value. Those are fed into that string just the way they're supposed to be, right? And then it does the calculation and it gives us an output, right? And this is indicating that you're out of space, basically, right? You're short by a couple 2,000 megs or whatever. And then that string is stored in this variable, which then is used here to build this string. And I said variable, but I meant constant. And then it's stored in this constant. You guys seeing that? And so this is a really common thing. Often when we're running a function that returns a value, a real common way to run one is to store it somewhere. So whatever's coming back, we immediately store it. So it's not unusual to see either a let or a var with a constant or variable name here, an equal sign. And remember, the equal sign says, take everything on the right side of the equal sign and store it in the thing on the left. So what is it storing? What it's returning. You guys catching that now? Right? So it's storing what we're returning, and then that can be used for subsequent work later, right? So what ends up happening here is that we're gonna append really the person's name to that whole statement and then maybe put it on the screen. All right, so it says, recall that the definition of an expression is something that produces a value. Encountered mathematical expressions, right? So we did that a long time ago. You also learned that value literals are the simplest form, and a function calls another example of that sort of expression, right? But because it's evaluated and produces a value, then we take that, we can use it anywhere in the program. This is what the important part is. All right, so now they're asking us, try making your own function that returns a value. So I'm gonna just kind of create one really quick, and I'm trying to think of like something that makes a lot of sense. And let's see if we can kind of come up with something fun. All right, how about like what would be a good way to determine okay, how about this? Gas mileage. This is always a fun little calculation. So I'm going to set up the parameters for the function first. So here it is. There's my example. Now, to determine gas mileage, we probably need to think about what does it take to determine gas mileage? Well, one would be how many, okay, so gas mileage would be like how many miles per gallon your car gets, right? And how big your gas tank is. All right, so let's do tank size. That'll be, let's do it in round numbers. We'll do an integer. And then the other would be, we could just call it MPG, miles per gallon. And that would be also an integer. We'll just use round numbers. Now, what do we want to return? And I'll say a string at this point just to kind of follow the example, but it could be a number too, right? So that's a possibility. Now, inside here, let's set it up to do the calculation. So what we'll do is we'll say inside the function, we'll use our example here. And notice how they're using lets, right? And I'm going to stick with that convention. I'm going to say let, let's say, we'll call it range, the range of the vehicle, equal, oh, and apparently that's a keyword. Okay, let, what do we call that? Okay, how about car range? Maybe that's good. Equal, and then that's going to be the result of a calculation. So I'm going to say tank size times MPG, right? So we're going to multiply how many gallons you have in the tank by how much mileage you get per gallon. And that would equal our car range in miles. Right. Next thing that we have to do is add a return statement, and we've already decided to return a string, so we just start with double quotes, and we're just going to say your car, which holds, I don't know how many gallons, we're going to say tank size, and we'll say gallons, and gets MPG, and I'll say, and I'm just going to use MPG here because it describes miles per gallon, has a range of, and then we'll output car range like that. And really what we'll say is miles, right? So like, and this is a classic calculation. And you know what, if you ever travel a really long distance with a vehicle, right? If you guys ever do a long road trip, it's a really good number to know. Like I know for some of my vehicles, how far I can go, like my van that got smashed yesterday. I have a broken fuel gauge, but I still kind of count the miles with an app. And I usually don't exceed 150 miles on a tank because it's not very fuel efficient. It's an old vehicle and only gets like 15 mpg. On one of my newer vehicles, when I usually drive to work, I average over 45 mpg because it's diesel, right? And I know that on my 13-gallon tank, I can hit almost 600 miles on a tank, which is huge for a little car. So let's see how this works now. So I could do something similar to what they have. And so let's, now that we have the function declared, let's do a couple of let statements. Let's say let tank, okay, let's say let tank equal for me, it'll be 13. Let mileage equal, I think it's like 46 technically, or 47. I think it might even be higher. And then we'll do the same thing they did. We'll say let car message equal, and what's it going to equal? Now we're going to call the function and we're going to say gas mileage, and we're going to feed in the values, but we're not going to type in a hard-coded number here. I'm going to call the variable, so I'm going to say tank, and then for this one, I'm going to say mileage. I don't know if you guys are catching this, but when you fill out the one and you want to jump to the next, you hit the tab key and it pops you over. Or you can click on it, kind of fairly automatic, right? Now that's stored in that message. And now we'll say let final message equal hi Takis, and then we're copying what they're doing, and then we're just going to add the car message, and of course I'm forgetting my double quotes, so Jomar, you didn't catch me on that.
All right.
Right, and then I'm going to just close that out. Now hopefully, so here we go. Your car, which holds 13 gallons, it gets 46 mpg, has a range of about 600 miles, and I think that's pretty impressive, and it actually gets better on the freeway, believe it or not. But hopefully you guys are getting this to work. Now I want you guys to note that we're not calling the function in a typical way. We're calling it as part of another statement. So it's on the right side of an equal sign. So it executes whatever it's returning, which is this string with the values placed in it, gets stored here. And then we're using that to create another message. And then ultimately, of course, if you wanted to do this, you could say print. And I'm going to do this just for matter of practice, and I think you guys should too. All we have to say is final message, and then that should pop up in the console.
One thing I noticed for let final message, it's not camel hump. Is that okay or not?
Oh, that's on me. Well, Jomar, the proof is it still works.
Yeah.
Right. This is just considered better practice to use the camel casing, but thank you for catching me on it.
Okay.
All right. We've been going for a little bit, so I think we're going to take a 5-minute break, if you guys are cool with that. So I'm going to pause the video here. We'll come back in 5 minutes. All right, so we're going to move on to the next playground page here, and this one's called Giving Values Back. And what they want us to kind of practice now, and they do kind of get into this mode here in the book or the playground as they're doing this, where they put forth these challenges and have us code through. And these aren't really the graded exercises, but it helps you build up to the exercises. So when you do them, they're not like so bedazzling, basically. All right, so it says, over the last few exercises, you developed a function that builds a sentence about your favorite thing and then prints the result to the console. Building the sentence and printing it are actually two separate jobs, right? And so this is kind of how you start to think as a programmer, by the way. There could be cases when you want to build the sentence but not print it to the console. You may want to do it further work on the sentence or display it on the screen. All right, so the exercise is write a function that takes the category of thing and favorite as arguments and returns a string. You should be able to call the function like this, right? So remember, here they're kind of doing a combo, right? So this is really the function call over here, right? So they're giving us the name and what the variable names are, right? And then this is just a constant where we're going to store it in the aftermath. And it's very, very common when you have a function that returns a value that you should have somewhere to store it. And that important concept you guys should definitely latch on to. And then ultimately the sentence should then have the value, so when it's all done running, my favorite food is cheese. All right. So let's try Building. All right, so let's take the process here. So the func, we want to call it make favorite. We got our parentheses there and our curly brackets. Now inside those parentheses, we are told to create something called category of thing. And that's going to be what? That's going to be a string, right? Because we're feeding the word food into it, so we know it's a string. And then favorite, which also is a string. Now, if we're building a sentence, then we're going to have a return type also of string. So that's dash greater than to do the return type. Then inside here, we have to build the statement now. Now we're already getting errors from the compiler, but this is a step-by-step process. So we need to build the sentence that says, my favorite food is cheese. Now, if you guys aren't remembering how to build it, you can always go back, right, to the previous pages. But it is possible here to go directly to the return statement. And you might not think this way quite yet, you know, if you're new to programming, but that's what I'm going to do. I'm going to actually start building the statement immediately. So my, and then this is favorite, and then we're going to talk about category of thing, right? So category of thing is space, and then the favorite, whatever that favorite is. Now, in the previous examples, and this is where I'm kind of having you think about it a little bit, we knew we were talking about food, right? In this example, it could be my favorite music is something, or my favorite car is, or whatever, my favorite color is. So that's kind of how we're set up here. But the category of thing feeds in, the favorite feeds in, and it's set up to generically return this statement. Right, so let's try running it. And we'll say let sentence equal all right, and then let's say call make favorite, and we'll say my favorite color is purple. Okay. All right, and then you can see your output over here. Now, it's kind of nice to see the output, right? To make sure that it's working. They want us to call it a few different times with a few different things. Now, here's where it gets kind of a little tricky, right? Because if we're using a let statement for sentence, I can't reuse it, right? So I could make it a var. That would be one possibility. Or I can just say let sentence 2 equal. And the whole point of this is to practice with the tool, ultimately. My favorite music is heavy metal. Okay, to make it colorful, right? So there we go. Right, so now they're making the point, and they're saying, now that you have your results, you can use string interpolation. Okay, so that's what the slash is, right? To combine them into a self-introductions. Yours might look something like this. So let's do that too. So let's say let introduction equal, and I'm going to say, oops, hello, hello, my name is, and then you can have, for example, I say sentence. So I'm using the word sentence, right? So I'm going to say sentence. We got to do string interpolation here. sentence and then we'll do sentence 2. Now you might have very different names for these, right? And then you can of course see the output here on the side. So it says, hello, my name is Takis. My favorite color is purple and my favorite music is heavy metal. And you know, the and in there is not working too well, right? So I'm seeing that and that's going away, right? Okay, so hopefully yours is working like that, but this is kind of the point. So we're creating, we're storing, we're calling it back, and we're utilizing, right? So we're returning values. All right, let's move on now to the next topic here. The next slide here says different kinds of functions, and now it's pointing out this interesting fact that says when you write functions, you now have 4 possible combinations of parameters and return values. Here's a summary that describes when you might use each type. All right. So here, you know, paint and hang a picture. So this is an example of no parameters going in and no return value. All right. How do we know this? Because there's nothing in the parentheses and there's nothing following the parentheses, right? Because if it had a return type, it would be indicated in the definition. So it says when you call a function that doesn't have any parameters and doesn't return a value, it's like saying, I want something to happen, but I don't particularly care how it's done or what happens to it later, right? So then that's actually pretty true, right? So if I run a function whose job is to put Beatles lyrics on the screens, okay, it did it, now it's done, great, let's move on, right? That's the point here. So this one says, imagine you ask an artist to create a painting for you. If you use a function like paint and hang picture, the artist will create whatever they want, then permanently hang the finished piece on the wall they like, maybe even in another city. So calling this function can save you a lot of work in making decisions, but also requires a lot of trust. The function does work on its own, but doesn't give back any information, and it might have an impact on something that you have no control over. And this is generally uncomfortable for programmers, by the way. Now, what's going to be interesting, right? And so we're going to play with this later. The BoogieBot dance moves are an example of this type of function, and the function tells the BoogieBot which move to do the work to make itself move. And so we're going to do this later. So in other words, we're going to have all these pre-created functions that tells it to like shake your leg or lift your arm or do the boogaloo or whatever, and it just does it, right? We have no control over what those things are. The other kind of function that we looked at is when we do pass in parameters. So here's an example of that. Here we can control the width and height and the dominant color, right? And it says this kind of function does work that changes depending on the arguments, but doesn't give anything back. There's no return statement, right? Pass values in, and we have some control over how it functions then, but we don't have any control over what it returns, right? And then ultimately, if we look at the byproduct of it, there's nothing really to look at aside from whatever the code does, right? The other type of function is where we run the function and return a value. So I want you to maybe even consider this scenario that you can call a function, not send anything to it, but it does return something ultimately. In this case, notice that we're returning a painting, right? So not a string, but actually an object, right? So, you know, think of it, you know, as you can pass nothing in and still get something back. And then, of course, the one that we've been playing with most recently is where we are sending stuff in and we are getting stuff back, right? And this is very common. So one of these 4 scenarios typically will happen with a function. What we learned initially is you just run something. Nothing is really returned, it just runs. We can send something and nothing is returned, or we can send nothing and something is returned. That's a little weird, but that's the thing. And then you can send something and return something. So those are the 4 possible scenarios here. And really what they're trying to do here is just point that out. So let's take it now to the next level. All right, so let's take a look at this. So it says when you were first introduced to functions, it was a good way to group things together. Each function was a building block for a larger program. So now that you've learned that functions can also take information in, do work, and return information, it really makes it a much more powerful component to work with, right? So it says this function can be used to build a list. So let's take a look at it. It's called list by adding, and then we can feed into it an item, and then have it, well, this variable is called toList, and that's also a string, and then that outputs a string. And so notice what this function does is it takes whatever the list is, puts in a blank line, and adds an item. So I want you to think about that for a second, right? Now, if we set up a variable called list and we set it equal to milk, now we can take that and feed in a new item, eggs, and then attach it to the list, which then stores back in the variable called list. This is really a clever programming approach if you think about it, because we're list building. So we have a variable now that's holding our list. We start it with milk to start with, and then every time we list by adding runs, it adds the new item, which is eggs here, and then bread here. And then you'll see in the sidebar here that you're starting to build a list. This isn't very pretty looking, but if I were to basically output this, and I could do that, so if we could do just a quick print here, you'll see down in the console, we have a list building, right? So that's optional at this point. We're really trying to demonstrate this concept that you have this object that's a variable, and then I can keep adding to it and then outputting it. And I think that's a powerful takeaway. It says, compare this to the way you were building lists before with the compound assignment. So we're saying before you were doing plus equals, putting in a blank line, and then adding a word. So what they're really trying to point out is this approach hides the complexity of it, and this is one of the benefits of doing functions, because when you utilize a function, so once again, I don't need to know how the car motor works in order to drive the car, is kind of a thing. And the same is true with a function. If you design a function well, it just does what it does. It hides the complexity from the person utilizing it, and it just does its work in a basically elegant fashion. And the other, plus to that, right, if you're looking at this approach, every time we were adding a blank line, well, that's really cumbersome. The function does the blank line adding for us and returns the results. All right, so now you get like all these building blocks that we're working with, and then the issue becomes what we call control flow, and this is really an important takeaway as well. It says, take a second to think about how functions affect the sequence of actions in your code. How can you figure out when each statement in your code will be executed? The order that a code execute in a program is called control flow. And we are predefining functions here, but none of the functions execute until we call them, either by storing it somewhere or by just brute force running it. All right, so we have our list, right? Our list by adding, and we're feeding in an item and adding to the list and then outputting a list. And then we say, let new list equal the list that we currently have. And then we're doing this, addition of a blank line. And I don't know if you guys are catching it, a dash and a space. That's just to make it look nicer, basically. So kind of like making bullet points, if you will. Totally optional, I would say. And then you add the new item, and then we're returning the new list. Now, what's fascinating about this, and I want you to think about this, is a constant, and it's operating inside the function, but every time we call the function, it's a new constant. That's kind of an interesting thought, right? That's why it keeps working. So instead of starting with something on the list here in this variable declaration, now we start with a blank. So we have a blank list to start, And then we also have another variable called the number of items, which is preset to 0. So think about this scenario. Now we have our list and we add milk to it, right? And then we add 1 to the count. So look at the output. Milk, we have 1 item. Then we add eggs, we add another item, the number goes up to 2. Then we add another item, bread, we add another, the list goes up to 3. And then ultimately, when you look at the print statement here, and I'm trying to pull it over, right? Your shopping list contains milk, eggs, and bread. And if you look at the console, notice the dash in the space. Your shopping list contains 3 items, and then it includes the lines and the dashes and everything, right? So that's what it's doing. All right. So what's fascinating about this and what they're trying to really point out is they're saying that on lines 15 and 16, which are these 2 lines, they execute in order, right? The next executable code is on line 18. So this is like what you sometimes don't see as a programmer immediately, because a function being declared doesn't execute any code. It's just ready to be executed. We've created a thing that we can execute, but we didn't execute it. On these 2 lines, we're still not executing the function. These are separate from that function. It doesn't execute until we get to this line. And then when it executes, whatever it's returning goes here, and then we're keeping a tally. All right. So really what they're trying to point out is the flow of the program is still all in these lines. We do utilize the code, but anytime we hit the function call, really what it's functionally doing is it's looking for this, finds it, executes it as it can, stores the output here, and then moves on. This is kind of standalone. Once again, we call the function, returns a value, stores it here, we move on, adds a value, call the function, et cetera, and then finally, we have the ability then, because we've been changing these variables, to pull those variable amounts back and make one output that we then do send to the console. And this is really more about how the program works, but ultimately, this on its own functions not at all. It must be called to function. And it's embedded into our normal program flow, which then becomes pretty important. All right. Next thing that they want to point out to us is naming things. So it says the function you defined early on was called like this. So remember the first hello thing, and we put a name into it. And it says there's 2 problems with this, right? So the one is the function has a side effect. The name is printed to the console, but this isn't clear from the name. A function has a side effect that should have a verb in the name. And this is where Swift gets a little weird. All right. So, and what they're really attempting to do here. So this is where I'm trying to give you guys some clarity. If you're brand new to programming, this is very unique to Swift, right? What they like us to do is, instead of maybe using here what you would logically call a variable in a function, they would prefer that you use it. So instead of a noun, you're using a verb, right? So they're saying, so that when you read the function call, it's print hello to whoever the person is. So when you're calling the function, notice print hello to Maya, it really reads very beautifully. You see that, right? And so that this is kind of a very, like, once again, Swifty approach to coding. And as you ramp up to the higher levels of it, they kind of expect you to do this. 2 doesn't really make sense as the name here, but it sure makes a lot of sense when you're reading it in the function call, because then what does this function do? Oh, print hello to Maya. Oh, that makes sense. You know, that's really the takeaway on this one. And that's really kind of an objective in Swift. You know, that's one of the language design features, basically, that functions in Swift should read as much like a sentence as possible, right? And their point is, hello name Maya is not a sentence. but print hello to Maya certainly is, right? Now they want us to experiment here, and they say, think of some more tasks that a program might perform, write them out as sentences, and then think about how those sentences would look as functions. For example, get the first letter of Swift would be get the first letter of Swift, right? I'm not going to type this out, but I think you guys are kind of getting the point, right? So one of the grand goals of Swift as a language was not only to kind of make a lot of the coding easier and easier to learn, but ultimately to become much more human readable. Because, you know, if I were to show you an example of like some Java code from one of my classes, you might look at it and go, what the hell is this doing? Right. And that's perfectly normal. The goal of Swift ultimately is that you can very easily look at it, very easily read it, and figure out what it's doing just by the way it's put together, right? Objective-C, the language underneath all this, does not do that, right? So Swift is really kind of an attempt to work with that. Now they're pointing out that this has a different problem that is being generated as a result. So now go down the rabbit hole one more step, okay? So look at this example at the top. It says on the previous page you saw how to change the definition so it has a clear purpose and reads like a sentence. However, doing that introduced a different problem. So here's the example. Print hello to, right? And then you say print hello to Chris. Makes total sense. Now you have the constant name to inside the function, which doesn't adhere to any of the rules you learned about naming variables with good names. So what Swift has done basically is they're addressing that by allowing you to basically use two names for the same thing. This is bizarre. This is very bizarre. But notice, this problem doesn't actually matter for a much simpler function like the one above, but you'll find it's confusing to read longer code where to is used as a name. So what we do then is you can use a different name for the parameter inside the function. So we will use to so that the person creating the function call still uses the word to, so it makes sense as a sentence. But inside the function, we're really using name as the variable name. So you'll see this double declaration. So one is the external call, one is the internal usage, which makes more sense to the programmer, right? So this is a little bit of a deeper dive. The function call still remains the same, right? Print hello to Chris, print hello to Johnny, makes total sense. But from the programmer standpoint, we realize we're providing this, we could call this maybe an alias if you want to think of it that way, but technically when we're doing this, we're creating what they call an argument label. And that means we're labeling this variable named name as to make the function call cleaner, right? And hopefully this is resonating with you guys. Practice makes perfect on this though. And it says, try changing the argument label and parameter name in the function above. And notice when you change the argument label, you have to update the places where the function is called. So here, if I call this, I don't know, top, I'm just doing that, you will get an error message pretty quickly. It takes a moment to populate, right? Or if I decide to change the variable name here, that will throw an error as well. Or if I'm not matching up with either one here. So now I think really kind of one of the grand goals is can I go hello plus 2? Does that work? Okay, so here's the answer. No. This argument label only applies externally. That's the important part here. This variable name only applies internally. Okay, if I wanted, so here's a deeper experiment. What if I said print hello and instead of using to just did name like this? Does that work? Apparently not. Yeah, and Jonathan, you are muted, by the way. I know
Print is spelled wrong.
Yeah. What's spelled wrong?
Your
Oh,
print.
Your
print
print
hello. Oh,
statement.
yeah, that's what's spelled wrong. Okay. So does name work though? Still doesn't work, right? Yeah. And notice the error message. It says incorrect argument label in call expected to. They're telling you what you should put in there. And so if you start using argument labels, which is encouraged in Swift, by the way, you have to use that external name always. The internal name applies to the function. The external name applies to the function call. Simple as that. And I think we experimented with that plenty. All right, let's move on to the next thing. All right. So here's a one that they're calling argument without a name. And it says, look at the print function. And we got print hello. When you call it, it has no argument label. That's not a problem because print hello makes sense on its own. This is kind of interesting. Besides, it's awkward to read print, thing to print, colon, hello, right? It doesn't really read well. And thing to print doesn't really add any information. So the parameter in print doesn't have an argument label. To declare a parameter without an argument label, you use the underscore. So in other words, what they're telling you is you can write it so yours is generic as well, right? So notice what we're doing down here. So instead of using the word to, right, we've really changed the name of the function. So we say print hello to, we can use this blank, which means we don't have to use the to and the colon. We just can do exactly what we do with the print command, which is we just feed it in. And then it will take in whatever you feed in. That's what the underscore means to me. It means a blank. And then it'll apply it to this function. So here's how we make print to hello without having to include that little prefix in there. All right, so now they're saying, call the print hello to function a few more times. Notice the auto completion pop-up shows the parameter name, not the argument label. So this is really to experiment more with the tool. So I call it. And notice now it doesn't have the to colon, it just has the spot for me to type. And I'm gonna just type, some nonsense here just to get it on the screen. But it autofills so that it just shows how it functions in terms of entering in the data. And this is, real frankly, in some cases, this is a cleaner approach and probably should be encouraged. It just depends on what you're doing. Okay, so, if you can't think of a good verb or whatever to put here to help it make it a sentence or whatever, you can always add the verb, out here, so this reads cleanly, this can become generic, and then you can feed whatever you want into it. You guys all good?
Yep.
Okay, great. All right, let's move on to the next one. Now we're getting to the exercise point here, right? So they're just kind of reviewing the stuff that we've learned so far. And I think that what we'll do at this point is we'll kind of go into the same mode that we've kind of been working in. So let's work on these exercises. What I'll do is I'll start out working with you guys on this first one. And then with the subsequent ones, I think we'll take a pause, work on them, share solutions, right? And do it like that. But all of these exercises, as you complete them, just as point of reference within the course, all of those are covered by this exercise. So you see verbing your noun is the first of 4 exercises in here. All of these go pretty quick, by the way. And, when you turn them in, you will basically screenshot each one of these exercises, put them in one document, or submit each screenshot separately, whatever, either way. But I'm just pointing out that it's all part of one exercise. All right, let's try to build this first one. So let's go. It says, remember back to the functions playground when you rewrote row your boat. In that playground, the functions were all very specific. To change the first line of the verse, you had to rewrite the function, right? Not very helpful, basically. All right. So Functions that can take arguments can be much more general. So it says, write a function that returns a sentence like row, row, row your boat when you give it a verb and then a noun, and the function would look like this when you call it. So in other words, when we're calling it, we'll say verb and noun, but it will return row, row, row your boat, right? And then you can drop in any word. So you could put paddle, paddle, paddle your canoe, for example. Right, so we need to build a function that does that. Now I'm going to get us started. So let's get started on writing this. And they have already implied a name. So I'm going to say function, opening line. Here's my parens. And then we assume a return here, right? Is this going to have a return? Okay, the answer
No,
to that
return
could
a
be-
string.
Yeah, I mean, maybe, right? I mean, we could
Mhm.
we could have the function printed out directly, or we could return the string. My suggestion would be to have it return a string just for the practice of it,
Mhm.
and then let's put in the curly brackets. All right. Now we do need to put stuff inside the parentheses here. So we could say verb, and that's probably going to be a string, right? Because we're going to send in text. And then we'll have noun. And then we will also send in a string. All right. So inside here, we will then say let first line, sounds good to me, equal. And then we can start building the string. So we can just say, and this is how I recommend that you do it. Use string interpolation. So we'll say verb, comma, space, verb, comma, space, oops, backslash, verb. So row, 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 your, and then whatever your noun is, noun, like so. All right. And then we have to get our return statement in there. And actually, we could, you know, honestly, we could actually skip this let statement. So one way you could do this is you could type return first line. That would be one way, right? You'll watch the panel there should populate a second here. And I'm not sure if I'm crashed or not, or we could just directly go to the return statement. And I think most experienced programmers tend to do that. So if we have no functional reason to reuse the information, we typically just go directly to the return statement. So we can just say return, right? I think my playground has crashed, by the way. So I'm restarting Xcode. And you can tell because Xcode took a second to quit there. I'm not really sure why. It should just pop right back to the same spot. Okay. Is it working for you guys?
Um,
Hold on, I
no.
had an error for a second there.
I don't think it is for me as well.
Yeah. It makes me
Oh.
wonder, where did we mess up?
But I might have messed up again. Okay.
Return expression.
Yeah, the fact that the play button is sitting here like this, to me, is indicating that something isn't working. So I'm gonna restart Xcode again. I'm gonna close the playground first, and then
Mhm.
Oh yeah.
quit Xcode. Count to 5. Turn around 3 times, pray to the east, and relaunch. Right? I know that's kind of silly to say that, but somewhere here where something is broken. I'm curious to see what's happening on your guys' end. Is yours working?
Mine isn't. It's just a
I'm not getting a return.
saying.
Okay. I think there must be something wrong in the way we're structuring it. So I'm gonna do a little bit of experimentation here. Do you guys remember how to comment out some code?
Yeah, highlight and then you can just backslash
All right.
or double backslash.
All right. Looks like the compiler is working here for whatever reason.
It's part of what we wrote out that didn't like it.
Okay, now I'm just having this like silly revelation right now, and this is really goofy. Well, why isn't it outputting anything? Well, because we're not giving it anything to output.
Oh,
So this is all right. So how do we got to test it basically is what they're saying. So let line equal, and you see we're not doing this part, and they told us to do it, right? So it shows how much we're listening. So, and I'm going to say paddle. Wait, I'm going to put quotes on that, right? And I'm going to paddle my canoe. Oops, I got to spell it sort of right. All right. So now it seems to be working. Now, isn't that interesting? And this is, accidental on my part, but I'm showing you like the same basic rule. It's like, hey, why is it not doing anything? Well, I'm not calling it. Right. So this is kind of going back to that. If I do not have some sort of a line that refers to it, then it's not going to do anything. And you'll notice, paddle, paddle, paddle your canoe. And then of course, if you want, of course, to put it in the console, you can do that too. And you know what? Honestly, I suggest that you do that. Is put it in the console. And then, of course, you can have fun with it. So you can set let line 2 equal opening line, and then you can say dig. And it looks like it crashed again. And let's see if this works. Dig, dig, dig your hole. How about that? And then I can also print line 2. Okay, you can get clever with the words that go in there, but if you're getting it to work and you guys are doing your screen capture, you might want to do kind of sort of what I'm doing here, which is maybe like pull the stuff in real tight, and then when you capture like this area here, then you can get all the outputs in there and all your code in there. So that's the first of 4 exercises in this set. So I think what would be good to do at this point is I'm going to mute myself. I'm going to move. Well, I'm going to move us forward to the next exercise first, and then I will mute myself while you guys work on it. And then when you guys are done, I want to have a reasonable amount of time set for this. We can revisit and take a look at what you guys are coming up with. So I think 5 to 10 minutes should be adequate, but let's take a look at what the exercise is first.
okay.
So the next one is called using return values. And I want you to notice, right? So there's 3 little components here to try, right? The other thing that I'm perfectly okay with is as you guys are working, if you get stuck and you want to talk to each other, or you want to help each other out, I'm totally cool with that, because I think that that's helpful, honestly. But let's look at what you're building. And it says, you've learned that functions are the building blocks of programs, but so far you've mostly used functions one at a time. In this exercise, you'll use the results of one function to influence the work that's done by another. All right, so now we go down the rabbit hole deeper, right? So the function impossible beliefs count takes several numbers of reportedly unlikely incidents. Then it prints the number of impossible things to be believed. You know, for example, pigs flying, frogs becoming princess, multiple lightning strikes. You know, these are unlikely events, basically, right? And so they add those things together. Notice how these are all integers, right? So like 2 pigs fly, 1 princess becomes, or frogs become prince, and 3 lightning strikes. It adds them all together, puts them in the total, and then prints the total output, right? And then this one, right? So your first task is to update that so that instead of printing a value, it returns an integer. All right. And remember, when you return a value, it has to have somewhere to go. And then this one uses string interpolation. So impossible phrases, and then it builds this phrase to return, and it wants you to update that phrase. I'll let you guys read the rest of the instructions on your own. Like I said, I'll give you, you know, ballpark like 10 minutes or something like that. See where you guys are at, and then I'll check in with you. I am going to be muted, and the recording will be paused during that time. So speak freely if you need.
Okay.
If you guys want to share your screens, that's also allowable. You just go ahead and just do it. Mine will stay shared until one of you shares your screen, but the
Okay.
recording is now. So I've let everybody here work on these exercises for a little bit, and with mixed results, of course, and that's perfectly okay. Some of it's just based on like programming experience ultimately. But here's the author solution, and I think like the big takeaways here, and you can see I have the original version in the background, right? And basically what we're doing is we're converting this one from printing directly to actually returning a value. One of the keys, of course, to returning the total is to add that little piece here to make sure that it returns, and of course, add the return statement. If you add this one and not this, you get a compiler error. And if you add this and not that, you get a compiler error, you know, as kind of like a reminder, hey, you're trying to return something, you know, where is it, basically? All right, so that one didn't really alter all that much. The next one did start out with a return statement in it, right? So you notice that really what they wanted you to do here is, instead of hard coding these values in, right, is to transition the function so that you can feed those things in dynamically. So if you look at the author's solution on that, it's actually pretty simple, right? You're just taking each one of these lets here and you're converting them into parameters that you're passing in. So this is a number, so we set it as an integer. This one's a string, so we set it as a string. The return type is string, that was already set. And then really all you're doing is, instead of pulling the values from inside the function, you're pulling them from the parameter pass. You know, so that's coming from the external world. Finally, this one had you take kind of a combo of these things, right? The impossible things phrase and the impossible beliefs count, and had you store those in constants, but then you had to do the function call and send values. So you're calling the first one, and then you're calling the second one, and hopefully those come back. And then, you know, the second phrase, if you will, you know, you might have called it something different, is incorporating the first one in it right here, right? And then we're adding something to it, and then we're doing an output of the final. And here's what the author came up with as output. This is, you know, once again, code I didn't create. This is from the author directly, but I thought rather than walking through all the coding, you can kind of pick it up just as quickly just by looking at it. So this is what I would consider a solution on this. So if you were close, great. If you weren't, tweak, adjust, fix, and submit, basically is the response for that one. All right, let's move on to the next exercise. And this one focuses on argument labels. And, this one, if you remember, the goal of an argument label is that you have kind of the external reference, right? So this is how you call it externally, and this is what you call it internally, right? That's really kind of what argument labels do. There's also the option, and I don't think it's utilized here. And I'm looking at the author's solution already, so that's not good. Don't copy the answers. Here, so here they're omitting the labels, so you kind of already saw what the approach is, but you guys need to add those in. So I'll give you a few minutes on this and we'll take a look at the author's solution once again. So I'm going to pause the recording, having already given the answer. So like if you're watching the video or you already have the answer, but hey, whatever. All right, this one might have been a little trickier for you guys from what I understand, but let's take a look at like what the solution is. So like originally the function was set up in more of a traditional approach, right? So we have, for example, over here, just a regular variable name, right? The data type, variable name, data type, etc., and then a return type. Our job was to add argument labels so that if you were to feed this line of code into it, that it makes sense. Now remember, argument labels are what we use externally. Variable names are what you use internally. So really what they're saying here is these are the argument labels. So now this may or may not make sense to you because first of all, with reds, right? Do you notice how like here we say with reds and here it says reds?
Yeah.
Yeah. And so in other words, the first one needed to be changed.
Mm-hmm.
All right. Then they're saying score with reds, greens, and gold. So you got to think about how this reads as a sentence. The first one really needs to be changed. The others are already named what they're named, so that was one of the tricks. The other aspect is that you had to change the call here to say with reds and not reds, greens, golds, because we already know that wouldn't work. So if you're altering this, all we really have to change is with reds, right? And then you got to change the function call here with reds, and that should work. The other ones aren't changed, and I think this is a little sneaky on their part, like in terms of because the assumption is you should change all of them, right? And is that how you guys read it?
No. So when you showed the solution, it became very obvious on I can share my screen really quick if you want.
Yeah, please do. I'll stop the recording here for just a moment.
Okay, thank you.
We're now going to move on to the next exercise, which is no argument label. And it says some function names are descriptive enough that they don't need a label for their argument. To write a function that can be called with an argument only, you use blank where you normally specify the argument label. Right? The function below has an unnecessary argument label.
I don't think you're sharing.
Oh, I'm not sharing?
I don't think so.
Yeah, that's not good. That means I'm recording your faces, which you guys are like, no. Right, that's what you get for turning on your cameras, basically. Right.
Quick edit.
So, all right. So just to continue, it says you use a blank where you normally use the argument label. The function below has an unnecessary argument label. Remove the label so that the function is easier to read when it's called. Note, you'll still need the parameter name in order for the function code to run correctly. Okay, so if I'm going to run it, right, really what they want us to do is set it up so that we can remove that from here. Right, so it works more like the print command, basically, right? Except instead of printing, you're hollering, whatever. So what do I change up here to make that work?
See.
This one's painfully simple, by the way. So where would we
So
normally,
you would just add a like a space instead of phrase, right?
well, the underscore,
Yeah, the underscore.
right? And that's all it takes on this one. So you can see why, I'm not setting you off to work on this for 10 minutes because it's really a 1 minute thing. It's just a matter of recognizing it. But that's all it takes. And this is a really common technique, by the way. If you want to make it really easy for somebody to pass a value into your function, that's probably the easiest way. You come up with a name that's used internally, right? Great for the
Mhm.
programmer. Externally, you don't have to preface it with anything. You just send the data over and it works. So very, very common technique. Absolutely. So that one's a really easy fix. So that's an easy screenshot. And that basically wraps up this particular playground. So we made it all the way through this whole section. I am going to stop the recording. So this recording ends here.